everyone has completed the edits, and maybe if there is no wish to edit further, if everyone is done, let's go to the discussion of what has been edited. So feel free to enable cameras and the microphones if we need to discuss. So let's start from the first one by Q, just to go in order. From
Okay. T represent the trajectory of the time. Oh.
No, wait. No, it's correct. It's correct. You do not need to but here it should be lowercase t.
Okay.
Right? So
yeah, I did
depends
mistake.
on depends on lowercase t, and uppercase t is upper limit.
Yes, yes.
Later on, inverse population is important, so I can emphasize it. I don't know why it is green. I wasn't doing it green. Maybe it went automatically.
Who did that?
I just changed indentation here. Maybe it
okay, Professor, then turn into black.
Okay. A is definitely the lowest, not the highest. And
Professor, I think you changed something in the explanation.
If it is lowest of the interband transitions.
Okay.
And here I just suggest a couple of words about this MM peak.
Okay.
Let's see, maybe. This line, M line was wrong.
Oh yeah.
Do you agree?
Yes, yes.
So it should look this way.
Okay.
From LUMO +1 to LUMO, and from HOMO -1 to HOMO.
Okay.
Because the energy of M transition is much smaller than the energy of A transition.
Then I have to explain that that one in the figure 2. Figure 2 or figure 3? Yeah, figure 2.
Yes.
Okay.
Okay.
Yep.
Let's ask if anyone had questions to KS work, or everyone believes it is perfect.
I'm surprised why today Amir didn't say anything. Amir?
He just thinks,
what happened?
He thinks your work is perfect.
Of course, it is. You did a good job. However, we discuss privately in the office a lot, so I think you know what's going on.
Okay. Let's go to the. If there are no more questions, let's go to another one. So I think there are not many questions to Aaron's work as well. But if it will be recorded and he will be able to see the recordings. And he wrote that he did basically everything except introduction. Let's go and see if there were comments. Just a second. Oh, we were on recording while editing, which is strange. I wanted to stop it. Okay, let's keep going. Yeah, he did a great graphical abstract. What are conclusions? No. Okay. I think everyone was happy and didn't find anything to improve. Okay. It's maybe one may have expected some suggestions and comments, but it's encouraging if everything looks great. Are there any verbal comments or suggestions? Questions 1, questions 2, questions 3. No suggestions. Let's look on any comments to the work by Samir. So his abstract is not yet ready, and September 28th we can skip. November 16 you can also skip. Today. Okay, let's see. Is it? Is this question relates to this place or to some?
Yes, to this place.
Okay, let's look. On one hand, to consider exact quantum propagation of both nuclear and debris. Yes, this would be good specification. So let's swap the order. Both electronic and nuclear degrees of freedom for a certain what normal mode interatomic distance. Let's keep it this way. Oh no, I missed the buttons. Instead of recording, I tapped stop recording.
Oops. Yeah, we had a very valuable discussion with you. Okay. No problem.
Okay. Did you discuss everything on your work?
The last table, I think you put some comments.
So if you want, one can add also rate of dissipation and check if the rate of charge transfer is the same or different compared to this rate of dissipation.
Mm-hmm. So first, before discussing them, do you still keep? We need to keep that blank column. So the maximum dipole was the same for all models. So it may bring some criticism.
Before submitting to journal, we either populate it with something or remove. Of course, no one.
No, I'm talking about removing that when it's constant, right?
But it will be just this value, right? Oh, dipole at maximum current is no, yes. We do not need it. We do not need it.
Okay, so maybe I can replace that by KE or KH. Mm-hmm. So for the energy dissipation, you strongly recommend that to have it in this work, or we can skip.
If it is not very hard, it's better to do it because the code computes it anyway, and it tells something useful about the system. We can learn more about its properties. Okay. But it's up to you. It's much healthier if you like steer and navigate what you do based on your understanding of the problem.
Okay.
Okay. Any questions to Amir? Questions 1, questions 2, questions 3. Let's quickly look on KS work and.
Thank you.
So let's see. It looks like everyone believes
Hello,
it is
Professor.
perfect. Everyone believes it's perfect. There are no comments.
No, I need to show one thing. If you give me permission.
I will make you a co-host in a second. Just wait. Let's go over the things.
Yeah. Oh, I need your permission, Professor.
Yeah. Did you choose this one, panel D?
Yes, I already did.
So it should show 0.09 is much smaller. It's not this big arrow.
Yes.
Participants.
Professor, I just need to show one thing to you.
Yes. Just wait.
Okay. Okay. So this one, actually, I replot this graph. And
excellent. This is truly perfect. Would you
this one perfect?
This is perfect, but would you please go to even smaller? Look for such small values where this purple line will intersect with y-axis.
No,
if it is not possible, we'll decide, consult together and decide. But it will be so much more.
Last time I remember I sent you this same graph, y-axis up to 10 to the power minus 16. Even I tried.
Can you please resend me? I don't remember it. Maybe I missed it.
Okay, so it's impossible to touch this line, this purple and the blue line in the y-axis.
You know what? Wait. If you do a little experiment, if you change the width of the line, make it twice as bigger, and then redo this absorption spectrum, then this purple line should be not as dramatic, should go more shallower. So the value at which the absorption line bumps into y-axis depends on the width parameter.
Width parameter.
Width parameter. When you convert oscillator strength into spectrum,
okay,
it tells select the line broadening parameter. Suggested value is 0.01. And you can do it like 0.1 or 0.2. And then this figure will dramatically change. Please try. It will be very, very interesting and healthy. Anything?
Width parameter, right?
Width.
Parameter.
Line broadening.
Okay. Yeah, this one.
Yeah, but I'm very happy we understand each other in what is needed for this figure.
And also I changed this one.
Okay, much better.
I just need to add there.
And for panel C, it also should be the horizontal line, not vertical.
Horizontal?
Yes.
Because this one.
Just a second. Let me quickly request.
Approve. Yeah. Okay, I understand. From here to this.
Okay. Do you want to show anything else on your shared screen?
No, I think it's okay.
Okay, then let's look quickly on the
instruction.
Sure. Okay, yes. If you, yeah, maybe this is not sufficient, but if you change the parameter, it will be seen.
Yeah, I will do that.
Okay, yeah, and then we will go back to debugging the text, but this is the main figure of this work,
Mm-hmm.
and it's a good investment to look on it in all details.
Yes, sure.
Anyone wanted to give Kia some suggestions? If no, I think we are done. So from now on, we will work more on the one-to-one individual basis on these papers and think about next wave of papers in new semester. There will be undergraduate written reports on Friday, December 3rd, and oral reports on Friday, December 10th. You all are welcome guests to it will be 11 a.m. on Fridays. You will be very welcome guests to visit, either just observe or contribute to asking questions or providing feedback if your schedule allows. Okay, meeting is done. Everyone is welcome to disconnect, and I think we want to talk at least with Yvonne briefly, one-to-one. If
do you have 1 or 2 minutes to ask one question that you can?
Okay, please do.
So I just copy and paste 2 comments from you in the chat line. So you commented on the DPP-ITIC. I didn't, for the first one, I didn't get what is the logic behind that. What is this pair is, do you think both of them can use as, can work as light absorber? And for the second one,
Yvonne, do you see this writings in the chat line? Do they look strange to you, or it looks clear? And someone here rose hand.
Yeah,
Kate,
Professor, actually, I want to leave. Like,
absolutely. We are done. Yeah, thank you.
I will send you email regarding those things.
Please do. Please do. Yeah, good night.
Good night.
Shubha
Shubha. Thank you. Bye, everyone.
I guess the first one is okay. I guess I need some context at least.
Okay.
Just the sentence itself, maybe it's okay for the first sentence.
it's related to figure 5. Figure 4, sorry.
Figure 4.
Yeah. DPP-ITIC.
So at initial time, both electron and hole can be placed either in the -6 or +4, right?
Mm-hmm.
So it means both polymers can serve as initial light absorber.
Okay, very good point. I need to highlight it more. But we, yeah, for the DPP PCBM, we didn't see that situation.
Mm-hmm.
Most of them started on the acceptor unit.
Mm-hmm. And is it clear about multiple channels of charge transfer, or it is not? It doesn't look clear.
No, for me, it's still a question.
Even no, it's no silly questions or silly answers. Even does it look clear for you, or you also not comfortable with the statement?
So which figure are we talking about for the second?
The same.
It reads okay.
So yeah, thank you for the support. In the top panel, the charge transfer formation goes by electron transfer from DPP to ITIC, right?
Mm-hmm.
So dashed line goes from negative to positive. And in the bottom panel, we get the same target state by hole transfer from ITIC to DPPP.
Mm-hmm.
So it's different channels of charge transfer. So one can achieve target state by different reactions, different initial conditions and different pathways.
What do you call it? Channel? What do you mean by channel?
I'm not sure if it is an appropriate word, but pathway. Here, dashed line in the top panel, dashed line goes from negative to positive. It's one channel. So electron migrates in space. And in the bottom panel, solid line goes from positive value to negative value. So hole transfers in space.
Okay, so maybe the problem is still by language. You mentioned this is a prerequisite of the photovoltaic effect. However,
I'm not standing and defending last 5 words.
Maybe favorable, because we didn't see this for PCBM, but still it's
favorable. Yes, favorable is okay.
Okay, I get your point. So this initial position and alternatively go from hole to electron or electron to hole. It's kind of desired behavior that we expect for photovoltaics.
Yes, it's like universal donor-acceptor pair.
Mm-hmm. Okay, I get your point. Sorry to wasting your time, Yulan.
No.
We're going to have a discussion.
I'm happy it came to discussion and it's very healthy.
Okay, thank you very much. Thank you for your time. I will address those comments and come back to you.
Okay.
Have a
excellent.
great night. Thank you. Goodbye, Dr. Han.
Thank you, Dr. Kirin. Thank you, Dr. Han. Have a great night. Bye.
Good night. Bye. Whew. How are you?
Good. How are you?